Hello, welcome to exercise 1G. We're looking at solving simultaneous equations. So you've just spent some time solving linear equations. So you might have been finding when 3x plus 1 equals 2 or something, and finding the value of x for which that whole thing works. Well, now we've got two equations and we're trying to find the values for x and y where both it works for both equations. And graphically what that looks like is if you've got two straight lines graphed and it's where the point where they meet, the values of x and y that work for both equations. There's two ways to do this: by substitution, which is my personal favourite and it's one that always works, even if sometimes it's a bit fiddly. And then there's elimination, which doesn't always work, but when it does, it can make your life a lot easier. So we're going to be learning both. This video is about substitution. Just having a look at the syllabus now, we've jumped ahead a fair bit in the syllabus for this one. We're now looking at, in a completely different section, solve practical problems involving a pair of simultaneous linear functions algebraically. So we're just doing a small chunk of this in a few exercises to come, or maybe next chapter. We're going to be doing this graphically, and we're going to be doing it for quadratic functions as well. You know, your y equals 3x squared take 2x plus 7 or something. So let's have a look at some example questions, because this will put it into context. We're trying to find, so for example 21a, we're trying to find the values of x and y where 3x take 2y equals 29 and 4x plus 1y equals 24. So we're trying to find the values of x and y that work for both of these equations. If we were to graph this, we'd have, our first one would be, oh wait, let me make this smaller so you can see what I'm actually doing. So we've got 3x take 2y equals 29, 2y equals 29. And if we were to graph that, it looks something like that. And the next one we would have had would be 4x plus y equals 24. Oh no, 4x plus y equals 24. And you can see those two straight lines that we graphed meet at this point. So that's the point where the value for x, which I think it's going to be 7, and the value for y, which is going to be -4, works. So 3 times 7 take 2 times -4 equals 29, and 4 times 7 plus -4 equals 24. We're going to find out algebraically, because you don't always have time to graph, and quite often doing it algebraically is a lot quicker anyway. So we're going to do this by substitution. Now, substitution is where you rearrange one of the equations to get like x equals or y equals, doesn't matter which. Usually there's a really easy one. It's usually the one that has the coefficient of 1. And then you substitute it into the other equation. So you can see when we have a look at the questions that we've got 3x take 2y equals 29, nothing easy there. 4x plus y equals 24. This plus y is screaming at me. That's telling me that I should rearrange that equation to end up with y equals, because it's going to be so easy to get rid of that 4x. I just need to subtract it. So let's have a look. We've got equation 2. We've got y, oh gosh, that ended up weirdly fat. I don't know why I'm being so mean to that. Okay, we've got y equals 24 take 4x, and I'm going to call that equation 2a. So now I have one of the equations where it's like y equals something. I can then substitute this whole equation that I've just made in for y in the first equation. So that's what I'm going to write myself an instruction: sub 2a in equation 1. And you always sub it into the other equation, otherwise you end up with 0 equals 0, and that's not hooray. So we've got 3x take 2y. Well, I've just told myself that y is going to be 24 take 4x equals 29. So that 24 take 4x came from y. That is y. Let's have a look. I'm going to expand those brackets. So I've got 3x take 2 times 24, 48, Negative 2 times negative 4x, positive 8x equals 29. I'm going to group my like terms. 3x plus 8x, I've got 11x. Take 48 equals 29. I'm going to add 48 to both sides, so I'm going to end up with 11x equals, well, what's 49 plus 29 plus 48? 17, carry the 1, 77. I'm going to divide both sides by 11. I'm going to end up with x equals 7, which is nice. And we already kind of spoiled that for ourselves by doing the graph earlier. We know x equals 7. Now I need to know what y equals, because I know the x value that works for both equations, but I don't know the y value that works for both equations. So we're going to now substitute this answer, x equals 7, into the thing that we created at the start, this y equals 24 take 4x, because I just have to chuck a value of x in here and I know straight away what y equals. There's no fiddling around. And I'm going to write that I'm subbing it in 2a because I labelled that 2a. So I've got y equals 24 minus 4x, so 4 times 7. So I've got y equals 24 take 28. Yeah, 7 times tables for the win, which means y equals negative 4. So x equals 7 and y equals minus 4. Hooray, we managed. Now let's look at B. Oh, so that was A. I should write that in the margin. Now let's do B. We've got y equals x squared and y equals x plus 2. Now one of these is going to be way easier to rearrange in y equals or x equals something. In fact, one of them already is. Y equals x plus 2. Well, this is already y equals something. And this is already, actually, there's an easy way and a hard way. I know y equals x plus 2 and I also know y equals x squared. So y doesn't change between those. So I know x plus 2. Oh, y. Get it, y. So I can just replace this y with x squared if I can choose a pen. So I've got x squared equals x plus 2. So what I did was sub 1 in 2. Doesn't matter, I didn't really need to write myself a note there, let's be honest. X squared equals x plus 2. I'm going to get everything over to one side. So I've got x squared take x take 2 equals 0. Like we did in exercise 1F, what we really need now is to factorize this, because then it's easy to solve. You could chuck this straight in the quadratic equation. X equals minus b plus minus the square root of b squared take 4ac all over 2a. I actually think this is one of the rare occasions where factorising is going to be easier. So what multiplies to give negative 2? That adds to give negative 1. Negative 2 and positive 1. So I've got x take 2, x plus 1 equals 0, which means x equals, I was about to skip a step, which means x take 2 equals 0 and x plus 1 equals 0, because when you times two things to equal 0, one of them or both of them must equal 0, so we do both answers, and which means x equals positive 2 and x equals negative 1. Now, we have two answers for x. We need to find both of the answers for y. Both of the answers for y. So, sub x equals 2 in y equals x squared. It's going to be so, we could do x equals 2 and y equals x squared, or x equals 2 and y equals x plus 2. We should get the same answer. And the next one, we're going to have to sub x equals minus 1 in y equals x squared. So positive 2 squared, y equals 2 squared is just 4. And negative 1 squared, brackets, because we're squaring a negative, y equals positive 1. And if we'd done that with y equals x plus 2, we would have had negative 1 plus 2 positive 1, or, 2 plus 2, which is 4. Good. So we have x equals 2, y equals 4, and x equals -1, y equals 1. Now if I graph this on GeoGebra, just to show you what it looks like, we've got y equals x squared. I'm going to delete these. Y equals x squared. Sorry, I'll move the thing so you can actually see what I put in there. And our next one is y equals x plus 2. There are two spots where they meet. First one is -1, +1. And the next one is 2, 4. Which is nice because that's actually what we got in our answer. Ooh, I need to move this one. Hello, ooh. Hello darkness, my old friend. There we go. So let's have a, oh, I keep clicking the wrong thing. You can't see where I'm clicking. So yes, hooray. They are the two spots where those two lines meet. They are the two values that work for both equations. That's simultaneous equations by substitution. It's not too hard. Next video will be elimination. So now we're doing solutions by elimination. This is a method that works sometimes. It's quite often fiddly. It's quite often not worth the time. But if your substitution's turning out to be an actual nightmare, wrong hands, it's reversed. If your substitution's an actual nightmare, this is one to then try. What we do is we take multiples of the equations so that one variable is eliminated when the equations are added or subtracted. It's kind of, I think of it like when you want the same number on the bottom of fractions when you're adding or subtracting them. We want the same numbers out the front of a variable when we're adding or subtracting. So either the x's or the y's. I'm going to go for example 22a. I'm actually going to aim for the same number out the front of the x's. So I could do that if I times this whole first equation by 4 and the whole second equation by 3, then I end up with 12x for both of them. So let's actually do that. So I'm going to times this whole first equation by 4 and this whole second equation by 3. So my first equation then becomes 12x take 8y equals 4 times 29. Well, 4 times 30 is 120, and I've lost another 4 because it was 29, not 30. So, 116. I'm going to call this 1a. And then my next equation, I'm timesing it all by 3, so I've got 12x plus 15y equals 24, and I'm going to call that 2a. Now, if I added these two equations together, I'd end up with 24x plus 7y equals, I don't know, that plus that, 140. Yes. But that's not going to get rid of any of the variables. What I could do instead is subtract the two equations. So what I'm actually going to do is I'm going to get that top equation and I'm going to subtract the bottom equation. Minus 2a. Because, well, firstly, I'm going to do this top to bottom. So 12x take 12x, 0x. Negative 8y take 15y, negative 23y. 116 take 24, 9, 92. Now I've got negative 23y equals 92. Then y is going to end up with 92 over negative 23, which is just, oh, where's my calculator? I don't have it. Google. 92 over 23. It's 4. I should have known that. No. It's negative 4 because it's negative 23. Then we know what y equals, we still don't know what x equals, so then we're going to substitute that answer into either of the equations. So I'm going to do it in the bottom one because I don't want to have to work with that 29. I don't know if 29. Sub y equals minus 4 in equation 2. I could have done it in 2a or 1a, but it's easier with a smaller equation with smaller numbers involved. So I've got 4x plus 5y, which is 5 times negative 4 equals 8. So I've got 4x, 5 times negative 4, negative 20 equals 8. 4x equals 28, because I've added 20 to both sides. X equals 7. So x equals 7, y equals negative 4. That's the answer. They're the 2 points where those two lines would meet. This second one is actually, I know it doesn't look it, it's actually quite easy because we've already got the same numbers in front of the x squareds and y squareds. Oh, I really want to do this one by substitution. So what I'm actually going to do is if I added both these equations, then that would get rid of the y squareds straight away. So I'm going to add 1 and 2. So x squared plus x squared gives me 2x squared. Y squared plus negative y squared gets rid of, makes it 0y squared. 53 plus 45 is something ending in 8. 3 plus 5 is 8, 98. So that means I have 2 x squared, not y squared. Following show team students, go to the front office. So I've got 2 y. Twice. It's not a y, it's an x. Gosh. 2x squared equals 98. Divide both sides by 2. I get x squared equals 49, which means x equals 7 and x equals negative 7. Now I need to know the y values, so I'm going to substitute both of those in. Sub into equation 1 or equation 2. I'm going to do it into equation 1 just because it's got a positive value in front of the y squared. So I've got 7 squared plus y squared equals 53, which gives me 49 plus y squared equals 53. 53 take 49, so y squared equals 4, y equals plus 2, and y equals minus 2. I could do this exact same thing with the negative 7, but negative 7 all squared still comes out as 49, so I'm not going to bother. Which means, therefore, x equals plus minus 7 and y equals plus minus 2. So if you were to graph both of these equations, x squared plus y squared equals 53, x squared take y squared equals 45, they would meet at these points. That's simultaneous equations by elimination. Have fun.